All right, so we're going to be reviewing Django validations, just getting practice with using validators and Django built-in validators, and also creating our own validators as needed. So I've already cloned this down. I've installed Django. I think I need to install, so I installed everything using the requirements.txt. One thing that I did know throw some students was the version here does matter. If you actually use the latest version of Django, some of your test cases will not pass because apparently the validators return something different. So that's something to be mindful of. So this is one example of why, having set or specific versions for your project can make sense. In this sense, it's Django 2.1, which is really old, happens to work with the test cases that we have here. If we upgrade the Django version, we're not going to have our project running as we want. And also, I know some students might have had some installation issues. Hopefully, you guys were able to work around that. I'm not sure what specifically might have been going wrong, but I ran my requirements.txt to install where these versions were, and that should allow me to run my project here. So taking a look at the README, we're basically given a bunch of, we're given a model, we're given test cases, and we just need to run Python manage tests to run through those test cases. And those test cases are expecting exceptions to be raised. So if I look at the tests in swim records test.py, we are expecting a validation error to be raised in all of these cases to verify that we actually have legit validators. So we have, I think, 8 test cases, so not too many. We need to go through them and make sure we pass all of them based on what they are expecting. All right, so if I go to my models, this is what our work is here. We need to implement all of these fields and any appropriate validators to make sure we are appropriately checking the values that we are storing into the database. So let's kind of get at this. I'm going to comment these out or uncomment these. Some things I need to add right off the bat. If you remember, char field needs to have a max length. So I'm just going to add that in right now. I don't know anything in particular, so let's go with 255 for all of these. So char field needs that. There you go. There you go. Integer field, Boolean field, date time field, those should be fine without a max length. All right, so that's one thing I definitely need. Let's take a look at our first test case and make sure we are adhering to it. So let me comment out some of these test cases. Start one at a time. And then, all right, so we want to validate the presence of a first name. We're going to try to run full clean. If you remember from our stand down yesterday or in our lecture yesterday, full clean will do a few things. It's going to call basically the validators on each field and then optionally call like a clean on the entire model together. And then there's also a validate unique in case we need unique records. But full clean is going to go through all those validators. If we get any of those validators find an error, it's going to raise a validation error, and we should hit this portion right here. Okay, so I'm going to go back to my models. Since I changed my models, I probably need to migrate here or make migrations. So Python, well, let's try running this, manage.py tests. Pretty sure I need to migrate here. Oh, guess not. All right, so that passed. We got a green dot. So let's take a look. The assertion here should have been this field cannot be blank. Notice I don't have any validators here. That's because there are some built-in validators for each field. The char field is not null by default. That's the behavior here. So if we have an empty swim record, we should automatically get this exception with this exact message. This is Django's error message that's coming back to us. So even without doing any additional validation or adding any validators, I passed the first test case here. All right, the same should be true for last name. There's nothing too different about last name. So Jesse, question?
So we don't need to do anything extra on that because that was what was throwing me the entire time because I'm like, all right, well, we passed it and it said you're going to pass it. So I was just making sure that there's nothing else we needed to do.
Yep. Yeah. So again, we're relying on built-in functionality here. So it does happen to work in the way we want it. So I'm going to guess the first 3 are going to be fine. Let me make sure the test cases say so. So let's do split screen so I don't have to keep switching. All right, so the first one says validates present first name, last name. These are going to be the same. So I'm not going to be too excited about that. Let's look at the third test case. Validates presence of a T name. Again, the same thing, same error message. This field cannot be blank. So this is, again, the default message that's thrown. But let's say, just to kind of change it up a little bit, if you guys are fine with it, what if I wanted to change this error message to be, empty value not allowed? Well, now, since I've changed my test case, this is not the text that Django is going to give back to me. So this test case will fail because I've decided, hey, I want to see empty value not allowed. In this case, I'll likely need to go to I need to add a validator so that I can control the message that's sent back, as in the validation error that's actually raised. And we'll see that, I think, with, we'll see what custom message here, but in this case, we can't just rely on Django to give us the message that we want, but we'll stick with the default messaging. All right, so the first three will basically pass, so long as you provide it the max length for the char field, because that's required. Not null is an inherent property for fields, so we don't need to validate it ourselves. Django will do that for us. Again, just to kind of, Elon, go for it.
Thank you. So I have a question about the blank attributes. I kind of just throw it in there, but since this one still passed, I was wondering, like, where should we use the blank, or is this the correct scenario?
So did you use blank equals true or false?
False.
False. So blank is used for like getting input from the user and then translating into your field here. So blank false says we cannot accept an empty value here. In this case, not null is for the database side. So blank, I don't think is going to make a difference. We could try it and see what happens.
If I may just point out something, I guess it's on the same topic. When I tried it, blank equals true didn't work, but null equals false or true. Like either one worked, and I looked it up, and apparently it's because with car fields and text fields, it's never actually stored as null in the database. It's just an empty string. So null, true, or false doesn't matter for the database side.
Interesting. I thought it would actually store nulls, but very good to know. So setting blank equals false does not seem to impact my test cases. If you said blank equals true, that will make our test cases fail, because now we're not going to get an exception. We're going to say full clean. All right, we got a blank value. That's fine. I think let's verify that. So let's run this. Yeah, so we failed the first name test because we are now accepting blank values. But based on the requirements here, we want to validate the presence of the first name. So blank should not be allowed here.
Okay, thank you.
Okay, so the first three are kind of gimmies. Let's go to the fourth test case. So over here. So validate presence of relay. None value must be either true or false. Let's see if this runs. So again, we have a Boolean field. This is different than a char field. We're creating an empty record. So we have no values for first name, last name, team name, relay. Those are all empty because we just have a blank record we create up here. Let's see if this error message, which is none value must either be true or false, actually comes back for us. Let me run this. Test. Okay, so we passed that also. Again, we're not doing much work right now. That's because Django already has some validations that it does automatically. Now, if we wanted to get around those validations, let's say we don't want Django to check for this, it would require a little bit more work, but it is possible to kind of circumvent what Django is doing. It requires using some inheritance and kind of overriding some functionality, but we're not too concerned about that. So this is checks for true, false already. All right, so first four, pretty simple, but we do have some more challenges ahead. So let's look at the next challenge, which is validate stroke. Now, Boolean is a default type. Like Django knows it's going to be true or false. Stroke is not like a defined data type. Django has no idea that what valid strokes are. So there's no way for Django to know that, hey, doggy paddle is not valid. We need to create a validator for our specific circumstance to raise the exception that we're kind of expecting here. So we look at this. We're creating a swim record with doggy paddle, but we should only accept these 5 strokes as being valid. So we should get a message saying doggy paddle is not a valid stroke. So to do that, we're going to need to create a validator here. Again, this is not, generic information. We have special data here. So I'm going to go to my stroke field. I'm going to add a validator in here. So it's going to be an array, and I could add 1 or more validators depending on my use case. In this case, I think I just need 1 validator and say validate stroke. Okay, so this is going to be a function we're going to create. I like creating a separate file for it, but in this case, since we're on the screen, I'm going to create this validator here. But usually I'll put my validators in one separate file and import them into here. But just to kind of keep everything on one screen here, I'm going to create validate stroke. Lyman?
Yeah, so when we were working on this yesterday, I kind of went off in the weeds and I found there's something you can pass into it called choices, where you can like limit the amount of choices that goes in there. Is that, I mean, it's not technically a validator, but have you ever seen or how you would actually use that? Would that
Yeah,
be like another layer or?
Yeah, I'm glad you're kind of looking into more Django capabilities. There is an ability to set choices. So choices is a keyword argument. This would be more for your user as they're inputting data. So choices will limit what options they can put in there.
Okay.
This would be kind of like a drop down on your front end.
Oh, okay.
Choices would be only the values they could select from.
Okay.
I'm curious if this will actually validate. I feel like you could still add additional values, but I'm not quite sure. So
Okay. I was just curious because I was looking into it and I was like, well, that looks like that could be a good way to force certain inputs for that field.
Yeah, no, I'm glad you're kind of exploring what Django has to offer. I'm not actually sure if choices will limit you to those choices or just offer those choices to the user, but any value can be set here for a chart field.
Perfect. Thank you.
Yep. Something to explore, but we're going to just go with validators. But again, there might be other ways to solve this. So validators validate stroke. We're going to take in a stroke value that's automatically going to be passed to our validator. Then we need to check if, let's do maybe valid strokes. And we want to populate them with these 5. Might make more sense to create this out here because it's a constant value. We don't need to keep recreating it. So let's make that caps, because in Python, there's no actual constant data type. But if you make it all caps, developers will know that you're intending it to be treated as a constant. So you have valid strokes over here. We want to check if stroke not in valid stroke. Okay, so for doggy paddle, it's going to be pass in doggy paddle as a stroke value. We want to see if that is not invalid strokes. We need to raise an exception. So validation error. And then the message will be, I think we need an F string here. So stroke value. Let me just copy this so I don't make a typo. It's not a valid stroke. All right, so we get in a stroke value. If it's not in our valid, list of valid strokes, we're going to raise a validation error with this specific message, and that should give us this exception. This is automatically going to be tied to the stroke field because, again, as the validators are being run, we know precisely what field this is being applied to. It's going to be called for this field right here. Lyman?
Does it matter where you initialize that variable for valid strokes? Could you also do it inside of the validator function versus having it outside of it?
Yeah, definitely can. And there might be arguments why this might make more sense because valid strokes is only used in this function. So yeah, maybe put it in there. I guess my only thinking was each time we call this function, valid strokes can be recreated versus if you put it outside, it's going to create once. But no, it makes more sense. I'm not too worried about, I guess, performance here. So yeah, we'll nest it here since we're using it in here. Good suggestion. All right, so now we have a validator. We specified on our stroke field that we want to use this additional validator. So Django should kind of tap into this validator, make this check, and if it fails that check, it's going to raise this validation error. Okay, so let's give this a run. Let's see if this works or if we need to add anything else. Clear this. Manage pi test. Okay, look at that. We passed the 5th test because, again, when we run full clean will eventually run this validator for the value that's in the stroke field. So whatever was stored in stroke, will we pass our validator, I'll go through this and realize, hey, not a valid stroke, raise an exception. Cool. All right, we've done 5/8 of our work. Let's go for number 6. Wish this was a little easier to read, but distance record must be greater to or equal to 50. All right, so it looks like they're creating a swim marker with distance equals 20, which should hit this. This should violate our requirements here because our minimum should be 50. So we need this message spit back out at us. Let's see what we can do here. So we did something for stroke. What if we did something for distance also? So let's say validate min distance, taking a distance value. I guess I'm doing it in the opposite way now. Pass. Okay, so distance, we want another validator. So I'm going to put validators here. I called it validate min distance. And then, okay, so we said 50 is our minimum. So we could hard code that, say min distance is 50, and then check if distance value is less than min distance, raise some exception. So it looks like we want to do this. Return validation error. We probably want to use an F string here so we don't have to repeat ourselves. So since we have a min distance variable, we'll use min distance here. All right, so let's see if this works. Again, validator should be called, and then we should return an appropriate message that should match what we're expecting here. Let's see if this runs. Okay, we failed that. That was not expected.
Does it matter if you return or raise that validation error?
Oh, it does matter. Thank you. Yep. Don't want to return it, want to raise it. Thanks, Tanner. All right, there we go. So we passed number 6. Now, this worked. We created our own validator. Wasn't doing anything too complicated, but this is a chance where we can use a built-in validator. So Django, if we go to the docs, go to validators, Django. There are some built-in validators that there's enough commonality that certain checks are done that Django just built them in for us. So we talked about a few of them, like email validator. You know, entering emails is pretty common. So Django just said, all right, we're going to create an email validator for you. But if you look at a few other ones, one thing you might notice in documentation is that, hey, there's a min value validator. That sounds sort of similar to what I'm doing. So let's explore it. Raises a validation error with a code of min value if a value is less than limit value. So it looks like we can, it's a class, we pass in limit value, and that should, handle the validation for us. So again, this kind of makes our work a little easier in that we can kind of rely on built-in functionality. So to do this, I need to import the validator. So we do from Django for validators, import min value validator. Right, so that is the validator I want to use. I'm importing it. So now instead of calling my own, it's going to comment my own out. I'm just going to use Django's. So I'm going to pass it the validator I want it to run. And then looking at documentation, we need to pass it the value we care about. So in this case, it's going to be 50. So we could add a 50 kind of hard coded there, but I'd recommend creating a variable for it. Just in case you want to change it, it's kind of clear. So I'll create a class variable right here, min distance, and use that right here. All right, so let's see if this still works. Again, I'm no longer using my own validator, but now I'm going to use this built-in validator. Let's see actually what happens. Run this. All right, so that passed. I want to make sure I'm getting what I want. So What if we change this to like 49? Would that work? Okay, so I changed it to 49. So notice what the error message was shown as. Right here, it says ensure this value is greater than or equal to 49. That's because I passed in 49. So like the validation is still raised, but I'm getting the wrong error from the min value validator error. So in this case, I want 50. One question I have, or one additional challenge is, all right, this is the default message that's sent back from that validator. And that's what we're checking against. What if I, in this case, wanted a custom message saying, hey, that value is, or let's say that value needs to be 50 or more, right? So if this is now my new message, question is, well, how can I solve this? Well, do I need to go back to my custom validator and say, all right, well, since we need a custom message, I'm going to need to add this here. All right, not a big deal. We already had this validator. Is this the only way to solve this? And the answer is no. This will work. So in this case, we have a custom validator, return our custom message. This should be fine. But we don't need to do this. We still have some flexibility, even though we use in built-in validators. So again, part of this requires reading documentation. If we go back to our docs, we notice that there's a limit value which we must pass. That's a mandatory parameter. There's an optional parameter for message. And message is actually going to let us override the default message if we want it. You actually dig into the source. So if you click on the source in the docs, it'll take you to the code. We kind of see what's going on here. So if we go to base validator, that's what every validator is inheriting from. Just kind of explore reading code. Here we have an init method. So notice we pass in a limit value and a message. If message is not none, it's going to actually store our message and use that somewhere else in our code. If we don't pass a message, it looks like it's not going to store an internal value and we'll use some other default. So that's what's going on behind the scenes, but I don't really need to worry about that. All I need to worry about is I have the ability to pass a message to my validator. So in this case, instead of using our own, we can still use the built-in validator, but pass in message as a parameter. So in this case, my message needs to be an F string, exactly what I have here. And there we go. This should still work, assuming I didn't make any mistakes here. Yeah, so now we override the message, but still use the built-in validator. Let's see if this passes. Fingers crossed. Yep, there we go. We still pass that test case. So we're using a built-in with a custom message. Django lets us do that. Any questions about that? Okay, I think we're doing well on time. So let's get through the last two. Does not allow records to be set in the future. So bad date, it's taking the current time and adding one day to it. And then we want to validate can't set record in the future. So again, question is there a built-in validator that's going to do this for me? Probably not, right? Because there's nothing inherent about setting dates in the future that's wrong. But for our case, it is going to be wrong. So we need to create a custom validator. We can do the same thing we've done before, where we add validators. Let's say validate not future. My naming isn't always the best. We have extra parentheses somehow. All right, we need to create this validator. Again, normally we'll create a separate file to add all these validators, just not to clutter up my models, but we'll do it here. It's going to take dates to check. And then we'll do a simple if date to check is greater than time zone. That now is what they're using. We need to import that time zone from utils. All right, so we're going to use that time zone module or function called now on it. If it's greater, then we need to raise that error. So raise validation error. Again, raise, not return. I made that mistake once. And we need to return whatever they expect. So can't set record in the future. Simple enough. Okay, hopefully this math works with time zone. or this comparison works. Let's see if this works. Fingers crossed. All right, cool. 7 dots. We are almost to the finish line. Now we get to the last challenge, and this one is slightly different than our past challenges here. We do not want to allow records to be broken before the record date. So we look at our model down here. We have 2 fields that kind of hard to read with this wrapping. We have record date and we have record broken. In this case, we need to compare these values. So it's saying record broken date cannot be before the original record was broken or record was set. So we can't break a record if the record's never been set. Is idea here. So we need to actually check 2 different fields. That's not quite possible with our validators, right? Our validators don't have anything to do with our model directly. They are just functions that get passed one value, and that value corresponds to one field. In this case, we want to compare 2 fields to another. How can we achieve that with using validators? The answer is we need to implement a new function called clean, and it must be called clean. So we're going to define clean. This is a function, and we're going to do some logic here. I went over this briefly, I think, over Sandown, but I just want to reiterate it because it's important to know how we get to this point. How do I know that I need to override clean? Let's dig into the code and kind of follow the trail. We did this a bit yesterday, so hopefully you guys understand what I'm doing. So I'm going to full clean. This is Django's code. This is nothing I've written. I'm trying to look at what full clean is actually doing. And documentation, if you read documentation, we can do that too. Full clean, Django. Model instance reference. So again, you can look at the code. Documentation is usually easier to parse through, but this is what I'm kind of going through. Full clean is going to call 3 items. It's going to call clean fields, right? I'm just reading this section right here. This method called clean fields, clean, and validate unique. So what I'm doing here is model.clean is a base function that's coming into my model right here. I'm inheriting from models.model. So this model class has a clean function in its implementation. So if we actually looked at it, it's somewhere down here, self.clean. If I went to that, this is the model. This is model's clean function. In this case, there's literally nothing going on here, but this function exists. This function is called by the full clean method. The reason I can kind of hook into that is because I am naming this function the same as this function right here. Obviously, I need a self. That's what I forgot. The reason, so because these functions are named the same, when the base class calls the clean function, so if I can go back to full clean. Full clean. All right. So again, if I go back here, when we call self.clean right here, it's actually going to call my function over here, not the function within the model class. And that's how inheritance works. Since we have an instance of swim record, when we call self.clean from a base, it's going to go back up to the swim record and say, hey, do you have a method called clean that I can call? In this case, we are going to create it. So it's going to call our method, not necessarily call the base method. Sean, you had a question?
Yeah, so is there ever a time that you'll actually change that clean method in the base.py?
No, so we should never modify the base code. Django has everything created for us. We should not be modifying Django code. If we need to modify functionality, we should inherit from any particular class and then override it in our own code. But good question. Yeah, so never touch the base files here. I mean, you can, but that's not what developers are expected to do. You're expected to override functionality and implement what you want. But there's nothing stopping me from modifying this code. I can, but it's probably going to break something else, most likely. So I'm not going to touch it. Okay, so we have this clean method. The reason we need this clean method is, again, let's go back to documentation. I know this gets old, but hopefully you guys understand this is part of the game. So if I look at the model.clean method, let's read about it. So this method should be used to provide custom model validation to modify attributes if your model is desired. For instance, you can use it to automatically provide a value of field, or do validation requires access to more than one field. This is the reason we are using the clean method. We want to provide validation that requires access to more than one field. In this case, we need to have access to both record broken date and record date. So that's why we need to do it in the clean method and cannot do it in just a single validation for a single field. Okay, So with my clean method, I mentioned this yesterday. Good practice is to always call your base function unless you have a reason not to. So what I mean by that is I'm going to call super and then clean. I think Andrew Tran mentioned this or asked this. Well, we verified that the clean method in the base class is literally doing nothing. Do we still need to call it? And the answer is yes, we should still call this. Call the base class. We shouldn't assume that this is always going to do nothing, right? So my example yesterday was, what if Django 5.0 comes out tomorrow and they add a print statement here saying print donuts, right? I should still honor what the base class is doing and then add on top of it, unless I explicitly know that I don't want to print out donuts from the base class, right? So again, Django comes up with a new version, they add some functionality in my clean method. I should still allow the base class to do what it wants. So I shouldn't always assume it's going to do nothing, therefore I don't need to call it. That's the wrong approach to take. We should make this flexible where we call the base class, let it do what it wants to, then we're going to add on top of it by adding code here. All right, so keep that in mind. Good practice is to always call your base class function unless you have a reason not to. So kind of store that in your head for inheritance. But now we have access to the clean method. Let's look at our test case, just to remember what we're trying to do here. Oops, that's not a file. All right, here. We want to, record broken date should not be before the record date. So we need to do some comparison here. We'll do if self dot record broken date is less than the record date. So I guess you could break the record on the same day you set it. So if it's less than record date, we need to raise some exception. Validation error as we go with. The small difference for our clean method is we need to tie this error to a particular field. For our validators up here, we know what, like Django knows what field's being validated. So we raise a validation error with a generic message. It's going to attach it to that field for the list of errors for that field. Here in the clean method, there's no one field we're validating. It's like the whole record. So our validation error should pass a dictionary, and the dictionary should have the field that we care about. So it looks like record broken date is where the error should be stored. So we'll do record broken date. That is the violating field. And then whatever message we want here. So can't break record before record is set. It's going to copy and paste because my level of typos is ridiculous. All right, there we go. So we are checking what we want to check in our clean method because we need to compare two fields, and that will raise a validation error if we don't meet that criteria. So with this in place, again, when we call full clean right here, eventually it's going to call back to our clean method here and run this code. So let's give this a try. See if this passes. We got an error. None type. That's not good. How did that happen? Self.record date, record broken date. Sean, you have a question, comment?
Oh yeah, it was just a quick question. Why do you have to put that raise exception on like after the full clean again? I think I missed that part.
Right here?
Yeah.
Oh, this is just ensuring that our test raises an error if it gets to this point and exception wasn't raised. So we are expecting full clean to raise an exception. So it should go execute this and execute this. It should never hit this line. If it hits this line, we're just going to raise an exception to fail our test case.
Gotcha. Thank you.
So it looks like
Ankur, we had this issue. We just had to add like a statement beforehand saying like to check if it's none, because in this case, in the test case, it's none. Like before you have the less than or more statement.
Gotcha. Yeah, appreciate the help there. So I just want to make sure I understand. So record date is now. So do you guys know why it was a none value? Like looking at this, we are setting a record date. But okay. So self record. I think I remember seeing this somewhere, but yeah, I don't know why.
So the reason why is for your other test cases where you're passing in null values, it's going to hit that clean as well.
Okay, but I would think that this record overrides it. All right, we'll go with this. That Thank you for assistance. That would probably take me a hot second to figure out. All right, so we're checking if these are not null. I'm not going to compare against null because a none value is a falsy value. So in this case, I'm just going to check if these are not none values, then go ahead and do this. Let's see if that puts us to here. Oh, sorry, John, I just caught what you're saying. The other test cases are going to call clean. I see. Yeah. Took me a second. All right, there we go. So for this method, we are passing it by comparing it in our clean method. Make sure that our broken date is not before our record date. And cool. Sorry, I have some vacuuming going on behind me, but all right, that completes our challenge here. Any questions about using validators? Hopefully you guys were able to get through this challenge and kind of understand, again, the whole piece, all the wheels that are turning behind the scenes between you specifying a validator and then Django calling it, you specifying a clean method and Django calling it. All that happens because of full clean behind the scenes. Let's go with Andrew.
I'm just trying to understand what the full clean method does in the larger picture. So every time we create an object, we're going to run the full clean. And if it gets an exception from that, we know that we won't save it, that we shouldn't save it to our database, right? Is like,
yep,
what
100%.
Like the purpose of it.
You summarized it really well. Yeah. So we want to validate on the server side so that our database does not have to do the validations. And sometimes our database can't do all the validations. Like doing a validation that's like, swim records. This is probably not easy to implement in your database. So that's why you want to, make sure you validate for your requirements in your server and don't rely on your database to do all the validation. That's why we run full clean. If this fails, then we should not save this record. So in fact, like, I'm not sure why save is here first. Save should actually be here, meaning we create this record, validate. If it passes this, only then save it. I'm not sure why the test case is like this, but maybe there's a reason for it. Elin.
Thank you. Sorry if you have already went over this, but I'm having a hard time understanding the reason. Is that the reason we're using clean is because it's an empty method that allow us to pass in multiple values, and instead the other two can only take single value. Is that kind of the reason?
Sort of, yeah. So what you said about the validators, these validators can only take one value and they validate a single field. So it's like, all right, is team name not empty? Is team name have a capital letter? We're only caring about this one field for that check. But for our last test case, we need to compare two different fields and one validator cannot do that. As we can't add a validator here and say, hey, what is your record broken date? That's just not how these validators are meant to work. So we needed to create a method specifically called clean and then add whatever functionality we want here. So in our clean method, all of our fields, we have access to them in this method. So again, here we're using self.record broken date and self.record date. I can use relay and team name if I wanted to. I have access to all the records in my clean method here. I don't have access to all the records here because notice that these are standalone functions versus this method is within my class. So I have access to self, which gives me access to all of these values. You said something about clean being empty method. That's just coincidental. As in, when we looked at the clean method in model, they happen to be doing nothing. That's not always the case. Usually base functions will be doing some functionality. In this case, clean is not doing anything. The only reason clean exists in a base class is so that we have the option to override it in a derived class, like we've done so here. Yelin, did that make sense? I want to make sure I didn't kind of butcher that explanation.
Yes, that really helped a lot. Thank you so much.
Thank you for asking. Jake?
Yeah, okay, so once you define clean, is it always going to be called on all of those, regardless of whether or not they have validator in them, or just ones that don't have some sort of validator specified?
Good question. Clean is always going to be called. For any time you call full clean, clean is always going to be called. Again, if we dig back into the code, I know this isn't always super helpful, but full clean does three things. So if I look at it, it's going to do this part, which is calling clean fields. That ultimately is going to call each individual validator that I've set up here. So I have, this validator, validate not future. This function clean fields will eventually call validate not future for that particular field. After all that's done, self.clean gets called, regardless of validators exist. So these validators are per field. Self.clean does not care if you have custom validators, built-in validators, or no validators. Clean just another part of the process that's going to get called. And there's also validate unique, which also gets called. We don't really need to talk about that for this example. Yeah, clean's always going to be called no matter what. You have 0 validators, you have, as many validators you want. It's not going to impact if clean gets called or not.
So is there a chance then that something that was already validated in a somewhere else or in previous, like in this case, we wanted clean to act specifically on record broken date. But is there a chance, like maybe depending on your logic in the clean method, that it might override a previous validation somehow, or something that passed already, and then it would come up with an error because some strange logic you put in there?
Yeah, that's a good question. So we do have a validator on record date. Let's actually see what this does, and then go from there. So if I change my test case to kind of break 2 things, I'm going to do bad dates. So I'm just going to copy this. So let's just see what actually happens here. So record bad date is what I'm setting for the record date. Record date is over here. It's kind of hard to parse. So we don't want time zone now. We want bad date for record date. And then this will still be in the past because our bad date's in the future. Let's actually see what message we get. Maybe we'll get the same message, or maybe we won't. I guess in this case, record broken date is, all right, that's not going to quite work. What if we made record broken date can also not be in the future? So I'm going to add this validator to record broken dates. And then I need to change my code here to be 4 days in the future, and then bad dates minus 1 day. All right. So basically, I'm setting a bad date for the record broken date and for the record date and the record broken date. It's kind of a tongue twister. All right. So validators. Let's try to run this. Let's just see what happens, and we'll go from there. Test. Okay, we still passed. So it looks like that this error message still gets through, even though this validator should have that error for record broken date. So let's actually print out this dictionary, and that might kind of give us an indication what's going on. So if I print out e.message dictionary, let's take a look at what that looks like. So my belief is that it's aggregating all these errors together. It's not going to override errors. I think all the errors get collected and kind of stored in this dictionary. Let's actually verify that. Okay, so notice that record date has can't set record in the future. Record broken date has 2 entries in here. It has both can't set record in the future and can't break record before it was set. So it looks like these errors append to each other. They don't override it. But that was a good question. Okay, cool.
Okay, actually, one more question.
Yeah, go for it.
There's this whole chicken and the egg thing that is bugging me with this. In the clean, we reference record broken date, like it's seemingly before it's actually validated. I feel like you need to assign a value to it in order to refer to it later. So like what's happening there? Is there like a temporary value, whatever we passed in, is being connected to the variable name record broken date, and it's not actually assigning it, or does it assign it, check in there, and then if it's not valid, like take it back? Like what's happening there exactly?
Yeah, so we are assigning it. So again, you can create invalid records. There's nothing that's going to stop you from putting in bad values. The only thing that stops you is when you call full clean. That's when it actually checks. So I could enter in, bad data, like bad data, and that's going to be fine. It's just a record. So here we are entering in a bad date and a bad date -1. So again, these have values in them. It's not like they're null or a temporary value. These are the values I've created on my record. They don't get wiped. Like full clean does not wipe them out or do anything to them. Full clean just says, hey, I'm checking your records. Hey, this is wrong. You had to handle it. It's not going to erase it or do anything else with the values. So once we set, record broken date to be bad date -1, that is the value for record broken date, regardless if it's valid or not. So when we get to
Okay.
clean, that's what it's checking. Whatever we set is what we're checking here.
Okay, so then in models, where you specify, like, I guess the confusing thing to me yesterday was that I don't see an actual assignment. I see you in tests, you try to create a record date, you assign, but now that's going to go to the constructor, to the class constructor in models, right? And then it's going to go through and try to assign each of those. But on the right side of the assignment operator, you've got some other thing going on there. You don't have the actual, like, you don't write bad date minus time delta days equal 1 over, like, so it seems like that's getting passed over to the models. If you can go back to the models. So that's getting passed over to here somehow. But all I'm seeing is like models.date field validators. Like, so is that sort of like a placeholder for the, like a second argument or something, like a second parameter?
I think I see the confusion. Yeah, I think I see the
like,
confusion. So these are class attributes and we're setting a value here. So it's not quite what you think. So again, the models are a little different. These aren't instance attributes, but they are treated like instance attributes. So if we go down into model, look at its init method. Let's see if we can find this. Yeah, this code's not going to be easy to read. I think I understand where you're coming from. No, this is not a temporary value. This is assigning how this field should be treated. And then when we set a value from the tests that I lost, this is actually like storing it on the instance level, not on the class level. Sorry. This is the data type, and then this is the value that we're setting. They're not overriding each other. I know it's confusing with the way the models are structured, but just kind of accept it that this is an instance attribute and not a class level attribute. So this is like calling an init method and passing the value to it. And this is just telling us what type it is.
okay, thank you.
Sorry, I know that's not satisfactory, but we'll try to cover it later if we need to. All right, so it's 10:49. Thank you for your questions. We're going to wrap up this challenge because we probably have enough for an hour ahead.